So now we will see register organization and memory segmentation. So already we have discussed during the architecture of 8086 regarding the registers which are there inside bus interface unit and execution unit. Just we will compile all those registers here. Now in case of 8086 we know that there are segment registers, now total memory of 8086 processor is divided in segments. So to access those segments or just to give the starting address of the segment, we are having segment registers. There are 4 segment registers. One is code segment, register, it is denoted by CS. Another is data segment register denoted by DS. Then stack segment register denoted by SS and extra segment register denoted by ES. So all these registers are 16-bit registers. Now suppose if this is a memory of 8086 processor, total we can access maximum 1 megabyte of memory. There may be possibility that you may use less than 1 megabyte in your system depending upon your requirement, but maximum it can be 1 megabyte. So let us assume this is 1 MB memory. So now in this 1 MB memory, total memory is divided in segments, right? So let us assume this is this portion is our code segment. This portion is our data segment. This portion is our stack segment, and this portion is, let us assume it is extra segment. Right? Now to specify the starting address of this code segment, we are having code segment register. To specify the starting address of our this data segment, we are having data segment register. To specify the starting address of our stack segment, we are having stack segment register, and to specify the starting address of our extra segment, we are having extra segment registers. Now the question is, these segment registers are of 16-bit, but for the 1 megabyte memory we require an address of 22 bits. 22 bits of address is required. So how we will get 20-bit address from these 16-bit registers? So these calculations, how to do that we will see in next lecture. But right now you just understand that there are these registers. These registers are used to specify the starting address of particular segment. And these registers are 16-bit register and they are the part of bus interface unit. Now after segment register, if you come, then there is general purpose register. General purpose registers. So there is AX register, BX register, CX register and DX register. These are called as general purpose register. So we can use these registers in our certain when we are using when we require some arithmetic or logical operation or any other type of processing, then we can store our data in these registers. So again, these registers are 16-bit registers, but there is one facility that we can use these registers as a 8-bit register also, right? So for example, for AX register, suppose these are the 16-bit of AX register, bit number 0, bit number 7, bit number 8, like this, bit number 15. So from bit number 0 to bit number 15, there are 16 bits. So these 16 bits are of AX registers. But this 16-bit register can be split into two 8-bit registers. So lower 8 bits, 0 to 7, are the lower 8 bits of this register, right? So these lower bits can be accessed by the name AL, right? So here L indicates lower 8 bits or lower byte. And same with the higher 8 bits of this AX register can be accessed by the name AH, right? Higher 8 bits of A register. Now same way for BX register also. This is a 16-bit register. Now this 16-bit register we can split in like this, two 8-bit registers. So this is bit number 0 and this is bit number 15. Here bit number 7, bit number 8. So 0 to 7 bits of BX register can be accessed by the name BL, and higher 8 bits of BX register can be accessed by the name BH. Same way for CX register also. Bit number 7, 0, 8, 15. So from here to 0 to bit number 7, we can access it by name CL, and from bit number 8 to bit number 15, this portion of the bit we can access by the name CH. Same way for register D. Bit number 0 to 7, we can access these bits by name DL, lower 8 bits of DX register. And bit number 8 to bit number 15 we can access by the name DH. So in our instruction we can use the name AX also, we can use the name AL also, we can use the name AH also, right? So I will write one simple instruction. Suppose we have written this instruction, move AX, 349 AH. So now in this what will happen? Since our destination, this is our destination and this is our source. Since our destination is AX, which is a 16-bit register, this means we can store a 16-bit number in AX register. So in this way, so this is a hexadecimal number, 4 digits are there. So these 4 digits indicate 16 bits in binary. So number 349A, this is hexadecimal number. So what will happen? With this instruction, this 349A will be loaded in AX, right? How it will be loaded? Lower 8 bits will be stored in AL register and higher 8 bits will be stored in AH register. So in this way, after this instruction, if we check the AX register, we will find there is 349A, where this 34 will be in AH and this 9A will be in AL, right? So same thing is applicable for all of these 4 registers. So these are general purpose registers, but they are having some special purpose also. Register AX is also called as accumulator. In many instructions, one of the operand some is in AX only, right? Suppose you are performing some operation where you require 2 numbers, right? So in many instructions, out of 2 numbers, 1 number must be in AX register. So this time it is having some special function. Now BX register, the special function of BX register is it is used to access the data in data segment in some of the instructions, right? So here this is suppose our data segment. In data segment we can store our content in the data segment. So exactly at which place our data is placed in data segment. So to access that data, we require BX register in some of the addressing modes, right? So the special function of BX is to access data in data segment in some addressing modes. Right? Now the special function of CX register is it can be used as a counter, right? Suppose in our one program we have written, suppose these some few set of instructions. These set of instructions we have written, and we want that these set of instructions should run for 5 number of times or 6 number of times, right? So to identify this, whether we have completely executed this loop for n number of times, so this CX register is used as a counter to check whether we have completely executed these instructions in n number of times or not. So this CX is used as a counter. And DX, suppose we are multiplying two 16-bit numbers. So if we are multiplying two 16-bit numbers, then the result will be more than 16-bit, right? Result will be more than 16-bit. So, but here we are having only the 16-bit registers only, right? So if result is more than 16-bit, then where all of these bits will be stored? So here in this case, after the multiplication of 16-bit numbers, the result is more than 16-bit. lower 16 bits of the result. Lower 16 bit of the result will be always stored in AX register, and higher 16 bit of the result will be stored in DX register. Right? So this register is used in multiplication instruction. So when we will see the instruction set of multiplication and division and other instruction, at that time we will come to know about the application of this DX register. So these are the general purpose register, as well as they serve some special function also. Now, apart from these registers, these segment registers and general purpose registers, there is pointers. There are the pointers. So one pointer is instruction pointer. Instruction pointer, IP. Another is base pointer. These are register. Instruction pointer, register. Base pointer, register. Instruction pointer register is denoted by IP, and base pointer register is denoted by BP. Now these registers is and there is another pointer, stack pointer. Stack pointer register denoted by SP. So again all these pointers are again 16-bit, and these pointers are used with some segment registers for the calculation of 20-bit physical address. Right? So instruction pointer is associated with CS register, right, with code segment register, to find out the physical address of our code, program code, where it is stored in code segment register, in code segment, right? So it is always associated with code segment. Now base pointer and stack pointer, these two pointers are associated with segment register, with stack segment register, for the calculation of 20-bit physical address of the data inside the stack segment, right? How that calculation will be done, so that thing we will discuss in other lecture. But right now you just understand this. Base pointer and stack pointer register is always associated with stack segment register, right? Instruction pointer is always associated with code segment register. So and all these three pointers are 16-bit, and yes, these pointers cannot be split in two 8-bit registers. Just like you just see this example, AX is a 16-bit register, but we can split it as two 8-bit registers. But here pointers we cannot split in two 8-bit. It can be used as a whole 16-bit. Same way the segment registers, SS, DS, SS, ES. Again these are 16-bit register, and we cannot split the segment register in two 8-bit registers, right? Okay, after pointers there are index register. Pointer registers. So in index registers there is source index register denoted by SI, and destination index register denoted by DI. Again, these are 16-bit registers. Now these 16-bit registers are also used, they are basically used for the calculation of 20-bit physical address, right? For the calculation of 20-bit physical address. Now under default condition, or you just understand this, SI register is always associated with data segment register, right? So it is used, SI register is used to calculate the physical address of our data which we have stored in data segment, right? So with the help of data segment register and SI register, we will calculate that 20-bit physical address. Now destination index register, this register is associated with DS register as well as ES register, right? So destination index register is used to calculate the 20-bit physical address of our data which we have stored in data segment or extra segment, right? So we will see about these all registers when we will discuss about the addressing mode. So then you will come to know whether DI is associated with data segment or extra segment, which particular segment, what are the various things. So in this way, these registers, how many registers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And there is instruction decoder register, right? So whatever instruction we will fetch from the memory, so it will go in a decoder section. In the decoder section there is an instruction decoder register, it will be stored there. After that, decoder will decode the meaning of the content of this register. Then it will generate various types of control signals to perform the execution of a particular instruction. So but this instruction is non-programmable. That programmer, we don't use this instruction in our this register in our instruction. So this is non-programmable register which is used internally by the processor, right? In this way, in total there are total 14 registers. Okay. Now we will see the memory segmentation. So memory segmentation we will continue in next lecture.